Hello everyone, I am Dr. Pranit. I'll be teaching you today chemistry. It will be the second part of the first chapter, that is some basic concepts of chemistry. I'm excited to connect with you all through a Knowledge Temple, a platform dedicated to providing quality education and mentorship for students across India. Here we get the structured learning, live lectures, mock test and performance-based rewards. Okay, so let's get started. So in the first part we studied about what is chemistry, what are some parts of chemistry, what is Indian chemistry. Then we learned about the classification that comes under the chemistry. Then we learned about what is an atom, what it consists of. Then we studied about the solid, the liquid and the gaseous substances. Okay, so now coming to the second part of that is today's lecture. It is the properties of matter and their measurements. Okay, today we will be learning about the properties of matter, the measurements of the physical properties, mass, volume, density, temperature, scientific notation, uncertainty and measurements. Okay, first, the properties of matter. So properties of matter basically are the characteristics of it. Okay, so it is broadly classification. This is the classification of the matter. Okay, so it is classified as the physical properties and chemical property. Physical, which can be seen physically, for example in shape, size and volume, and chemically it can be by chemical reaction such as atomic and molecular level. Okay, now reading about the physical properties, it can be measured without any changing in composition. Okay, so for example the color of the substance, the melting point, the boiling point, these we can say are the physical properties of a matter. Okay, these measurements do not require occurrence of chemical change. Now the chemical properties are the measurements that there is change in the composition of substances. Okay, for example burning of substances, acid-base nature and chemical reactivity. Okay, here the chemical change will occur during measurement. Okay, this is the very important point that you should note down during chemical properties. Now let's learn how the measurements of the physical properties is done. For example, if we take a 15 centimeter scale, ruler you say, so how you know it is a 15 centimeter? Here we did a measurement, right? We did a measurement. So for a particular scale we do a measurement, right, which has a unit for it. Okay, so for example for a physical property there should be some method or you can say a quantity to measure it, right? For example it can be say length, area and volume. Okay, now how to measure the physical quantity? First we can compare the physical quantity with the reference standard. For example we have two apples. Okay, this is an apple A, this is an apple B. This is 5. Suppose if an apple A is 10 kg, then we can, and suppose apple B is 5 kg more than apple A. So here what we did that we related the mass of the B to that of A. That is, we related that the mass of the B is 5 times more than mass of A. So here the mass of B we can say it is at 50 kg. So how did we get the 50 kg? We related the mass of the A with that of the B to find out the B. Okay, so mass standard is kilogram, that is kg. Next, the representation of the physical properties. It can be represented in the form of the magnitude and unit. For example, rural length is 15 centimeters. So here 15 is magnitude and centimeter is unit. Okay, so here physical quantity is equals to magnitude into unit. This is what we applied. Okay, so the systems of measurement, these are the early systems and the new systems. this is not that much important, so we can ignore it. Okay, not much important. Next, the system consists of two types. First, it is of fundamental and second is derived. Okay, fundamentally basically these are the principal units and these are the derived from principal units. Okay, so this is basically the chart which shows the symbol and SI unit. I just want you to just take a screenshot of this screen and make a note of it. Okay, now let's learn about what is the mass, volume, density and temperature. Okay, so mass is basically the amount of matter present in a substance. SI unit of mass is kilogram and it is determined by the analytical balance. Let's learn about the volume. The space occupied by a substance is volume. The SI unit of the volume is meter cube and the relation between different units of volume is 1 liter is equals to 1000 ml is equals to 100 centimeter cube is equals to 1 decimeter cube is equals to 1 T cube. So here we can apply a formula or one trick, that is, I will give you a trick to remember this, is milli centi deci liter deca hecto kilometer. So here, as we know, 1 liter is equals to 1000 ml. We can say 1 liter is equals to 1000 ml. So here you just keep adding the zeros. Now let's learn what is density. Density is the mass unit per volume. Here we can write the SI unit of is equals to mass upon volume. Mass is in kg, volume is in m cube. So we can write kg m minus 3. Okay. So now temperature. Temperature consists of three types in degree Celsius, in degree Fahrenheit and in Kelvin. Okay. So the conversion of it is very important, which is frequently asked. Is this Fahrenheit to degree Celsius and Kelvin to degree Celsius? Okay, these types of MCQs and numericals are asked on it. Okay, very important. Now let's learn about the scientific notations and uncertainty in the measurements. Okay, so now what is scientific notations? Okay, when we see a particular measurement, there is certain protocol to denote it or to add notation to it. To simplify the calculation, any number can be presented in terms of exponential notation. For example, here they have given Newton 10 raised to power n. So here n is equals to the digit term and here small n equals to exponent. So here the example is given as 2.32.508. Okay, so this can be written as 2.32508 into 10 raised to power 2. So 10 raised to power, when we multiply it, we can write as 232.508. This is nothing but this value. Okay, so this is basically the game of this 10 raised to power 2 and minus 2. Similarly, 1.16 can be written as 0.0016. Okay, yeah. So I just want you to solve this question. Yeah. So here they have given 6.65 into 10 raised to 4 plus 8.95 into 10 raised to power 3. So here we can say 6.65, so it can be written as 6 5 0 1 2 3 and 4 0 plus 8950. Okay, so just we have to add this value. So here it comes as 7.545. okay, this is the solution for it. Now let's learn what is the uncertainty of the measurement. For example, there is a, okay, this can be understood by a following example. For example, there is a Ram and there is a Sham. Okay, then there has been a teacher told to measure a particular cube. Okay, there is a matchbox. Okay, and they told that find the volume of it. Okay, this is the matchbox. Okay, so when it is told, when Ram measured, it came as 24 meter cube, but that of Sham measured was 22 kg meter cube. Okay, meter cube. Okay, so now this can be seen as the uncertainty is plus or minus 2. How plus or minus 2? We just subtracted it, like 224 and 22 comes as 2. So 2 is basically the uncertainty. Okay, so now significant figure. Okay, the uncertainty is indicated by writing the certain digits and last uncertain digit. Okay, so now it has certain rules to determine the significant figures. The first rule is all non-zero digits are significant. For example, 285, here the significant figures are 3. Here it is 0.2. For example, 0.025, here the significant numbers are 2. 0.25, here the significant numbers are 2. 0.25 numbers are 2. Okay, 0 preceding to the first non-zero digit are not significant. For example, here 0.00052, significant number is 2. 0.000052, significant number is still 2. 0 between the two non-zero digits are significant. For example, 2.005, here the significant numbers are 1, 2, 3 and 4. For example, 10.014, here the significant number are 1, 2, 3, 4 and 5. Okay, fourth rule is 0 at the end or right of a number are significant provided they are on the right side of the decimal point. For example, here they have given 0.200, here the significant numbers are 3. How these numbers are calculated? Now let's learn what is precision and accuracy. The precision is basically the closeness of our result in different attempts, and accuracy is the closeness of our result with actual result. Okay, here they have given a particular target image, and here we can see, here you can see there is neither precision nor accuracy. Here we can see the target is particularly crowded at a single region. Okay, here we can see it has precision but is not accurate. Here we can see precision and accuracy, because precision because they are together at a particular area, and accuracy because they are at a certain target. Let's solve this question. Okay, so they have given that calculate the significant figure of the following addition: the 12.11 plus 18.0 plus 1.012. So we have to first add the following, and we can say after adding it we can say the given series 3.112 and the significant number are 2. So what we learned today was a very short lecture but a very important lecture. Okay, today we learned about the physical properties, the chemical properties, the measurement of physical properties, the SI units, the mass, volume, density and the uncertainty. Here important thing to be noted down is first physical properties can be asked as an SEQ. Second is the SI units can be cast as match the columns. The chart. Okay, third is the precision and accuracy. These are some important points that should be remembered. Okay, I hope you liked this today's short lecture. Thank you for watching this lecture. If you liked it, you can join us on Knowledge Temple for a complete learning live classes and mentorship, and together let's make the learning engaging and rewarding. Thank you.